It's primarily going to be Chris and I, and we'll see about trading off. Bronson Pate and David Heller are doing the essentials, so they might drop by on Thursday, or we might swap people during the day. We'll see what works out. I don't know if Chris is going to be able to come in this time or not, because he's doing a leak DOS thing of his own, I believe. All right, so here's a rough overview. Regulatory stuff this morning, consent decrees afternoon, monitoring equipment. I don't think I saw that on that other schedule for today. That'll be a little bit later. Emission calculations, which is usually Chris's, but I can certainly cover that. Inventory management and regulatory application, so a lot of stuff about getting your speciation, tagging, and the right components identified as part of your system. Program management, some stuff on common pitfalls, best practices, and EPA's hot button of the moment, low leak technology. So we'll work through all of that stuff in one way or another. I did notice as we came through that there are a lot of, bona fide experts in here that have been doing this for 10 years or more. But there's also quite a few people in the 2 weeks to 18 months. So we're going to jump in on a lot of regulatory stuff here at a pretty high level. I apologize if that's tough on some of you that are just getting started. We do have a course called LDAR 101, and if you want to eat your lunch quickly and come back up here, if there anybody shows up, I'll come back and check, and we can run that during lunch if we want to bring some of you that are less experienced to get a quick, like a 45-minute overview of all aspects of LDAR as a lead-in. So just let me know at the break if anybody wants to do that. So ground rules on all this kind of stuff. We have a scheduled morning break, a lunch break, and an afternoon break. And those are longer than, when we do these away from the conference as well. Probably 2 more experts trainings and 4 more essentials trainings.
Sorry.
Oh, okay. And when we do those, our breaks are usually just maybe 5-10 minutes to get a drink, go to the bathroom, whatever, stand up, move around, get unpetrified. But the breaks here, since we have all the exhibitors at the conference, are longer. So you'll have some time to get down to the second floor, which is where the big conference hall is, across from where you registered, and be able to work your way through those. So you'll have an opportunity, 3 breaks a day during the training, and also breaks in between presentations on Wednesday. So there'll be time for you to get around and see everything that's in the exhibit booths as well. Questions, we got a pretty good sized group here, but I don't think it'll be any problem. As we're going, if a question occurs to you, just say something or hold up your hand or whatever you feel comfortable doing, and we'll try to address it. If it's something I know is going to be addressed in further slides in that module or a future module, I may ask you to pin and see if we answer your question there. If it's something that's outside of the pure material we have in presentations, then we'll go ahead and take it right at that point. Or if it's something that's so specific that I don't think the whole audience would benefit from it, we'll wait till a break and then take it as a side item and talk about it there. But go ahead and ask right away. Don't wait till the end, because half the time you'll forget what it was. That's what always happens to me. Of course, you're probably a little sharper than I am, so you won't forget that. Other than the scheduled breaks, anytime you need to take a break, go. We want some dialogue. It's tougher in this size group. Generally on the experts, we're dealing with 20 people, plus or minus 5. So you can do a little bit more interactive when you get with that size than 50-ish today. But we want to have all the dialogue we can. We are service providers. We do mainly audits and the training. But there's other people here that are in the same position, share the same positions. You're either site supervisors, LDAR coordinators, EHS managers, whatever. So your comments back and forth across the room to each other, oh, well, we're working these gray areas this morning, here's the way we've interpreted and handled that. Oh, well, this is what we do. And so you can gain a lot from all of that, so we encourage it. So some site-specific things, the restrooms. If you go out of here and turn right, you're going to go down. It looks like you're heading out onto a rooftop. Take a left before you get to that, right by where the fitness area is. And then down that hall just a little ways on your left are both the men's and women's restrooms. Telling people where phones are. I think they're in your pockets, right, or your purse. I mean, in the days of looking for a payphone, I think are pretty much gone, but I'm sure there's something available if you need one. But there's a business center I saw downstairs, I think the second floor, if you need to get any of the printing and faxing things done. Evacuation and safety, we've already had a couple of exercises this morning, but we will have to take a stairway down from here, and we'll all find that together when the time comes, because I haven't found it yet. And we'll let their fire alarm this morning be our safety moment, unless someone wants to volunteer an LDAR specific safety thought. No? You're still not quite awake? I'll toss one out just for the heck of it. It's good stuff. I think safety cultures in all of our plants just have been continuing to get stricter and stricter over the last 20 years, right? And the things that were tolerated before become less tolerated and eventually totally restricted. So one of the things that we see a lot of is valves on your sight glasses and level columns are usually run by the side of the ladder cage going up the column or the tower or whatever it is. And in the past, the rule was always, as long as you can maintain 3 points of contact, that you could stand there and use one hand to reach out and monitor those components from the ladder cage. Okay? And we're seeing, at this point, I would guess maybe 25 to 30% of the sites have gone away from that, because they were, I'm not aware of any accidents related to that. But it is the kind of thing that people have abused occasionally. Like I knew one fellow who was even a little more portly than me, that he would actually lop his belly over one of the ladder rungs and call that a point of contact. So you do get those kind of sea lawyers working in your plants and doing stuff. And I think even all of us that were trying to do a good job with it, between hook your elbow around and hold the data logger and that, and while you're reaching out with the other one to hold the probe and monitor, it is a little bit of a juggling act up in there. And I've never had any issues with it, but we are seeing more and more. So if you're not allowed to do that, how do you get those? Well, a lot of them become difficult to monitor because you're going to have to wear a harness and either one of the self-retracting lanyards that will allow you to climb up and then slowly climb down, stretch it out, and then do what you want to do. But it's like a seat belt that snaps as soon as you have an accelerated fall. So it'll stop you within a few inches. The other thing that's allowed as well that's a lot cheaper is just a body positioner. So it basically comes off of that and clips to one of the steps right in front of you. And so again, you can fall a maximum of, they're usually maybe a foot long, so you could fall about a foot. So either of those is what's being used and required in a growing number of plants. We already talked about that. Nobody said anything about what they wanted to get out of the course, but that's okay. We'll figure it out as we go through. They're not connected. You may have to help me get connected here. Chris? Okay. Good deal. How many of you have read things out of the 40 CFR, Code of Federal Regulations? Pretty much everybody, I assume. Okay. You know that EPA has worked hard to make those as simple and understandable as possible, right? Well, not so much. So what we're going to deal with here today, I should back up a step and say this is our third generation approach to covering regulations. The first generation is what I call brute force. You take NSPS VB, the grandfather of federal regs for LDAR, and you put together 75 bulleted slides that cover applicability, general standards, exemptions, pumps, compressors, right on through the rule. Okay, then you go, and then we'll go to triple G. Okay, you got off easy here. It's just going to refer back to that, so we only have about 6 slides for that. Then we'll go to HAN, and we have another 75 slides on HAN, and then we'll start going to clones of HAN and TT and UU, generic MAC standards, and then if you think about getting into a state to add on to that, you end up with 300 or 400 slides. Most of the people already know most of what's in there. And even if there was a little kernel of learning for them somewhere around the 127th slide, they're probably going to be in such a trance that they may not pick up on it anyway. So we've given up brute force altogether. We don't no longer do that at all. So for the essentials downstairs, we try to do the old parable of the fish. You give a man a fish, he's satiated for the day. You teach him how to fish, and he won't be hungry for the rest of his life. So we attempt to teach you how to read the regs. We're not going to tell you what's in them, but this is the way we go through and read and understand. Here's some of the variations of language that mean certain things. Here's some documents you can go to for clarification. This one, since it was an experts class, figured you know how to read them. You've been doing it for a while. And what we really need to do is look at the pinch points. What are the little aggravating things that people have disagreed about or misunderstood or kept you awake at night because there is uncertainty about what the EPA really wanted. So that's the way we're going to go through and cover this stuff. So on each of the issues that we're going to talk about, we'll start with kind of the language that's out there, what the rule says. And then we'll go through and look at anything that we've been able to find in terms of applicability determinations. This ADI, anybody in here not know about this and not be using it now? Go on. You're shy. I know some of these newcomers are not familiar with this. This goes back 30 odd years, very odd years, as a matter of fact. But it came from EPA not wanting to get egg on their face by answering the same question twice with different answers. So they started, as they started writing rules in the early 80s, they started getting people writing in with questions. And they realized if somebody in Region 1 answers it one way and somebody in Region 5 answers it another way, and heaven forbid somebody in Region 9 answers it a third way, they're going to be in big trouble because nobody's going to know what they're supposed to be doing, including EPA apparently. So they started at that time a clearinghouse. Early 80s, computers were novelty things as far as individuals having them, or even companies. Most companies and federal bureaus had one big computer that was payroll. That was the main thing it was used for. So they got a physical snail mail letter question, and they sent back a physical snail mail response. And to prevent stubbing their toes by answering it different in different areas, they set up a clearinghouse, which was literally a room with file cabinets. And whenever somebody officially answered one of these regulatory questions, and it says applicability determination, because when the rules first came out, most of the questions coming in was, I've got this kind of plant, do I have to follow that rule? So the answers were yes or no, and here's why, hopefully. They don't always do the why. Sometimes it's just a blank answer. So they would send in a copy to the questioner and send one to this room in Washington, and they would file these things away. And then if they get the next question they get, the first thing they do before they answer it was call up the clearinghouse manager and say, here's a question we've got, have you already answered this somewhere? And they would go through the files, and they had them cross-indexed for different things, and would try to figure it out. If they had, they would send them a copy of the answer that had already been sent out, and then that region would then copy that and send it on out to the new person. So they would keep the same story from area to area, person to person. By the 90s, they went ahead and scanned in all this stuff and put it into a database, and they gave the regions the ability to search and work that database, but they were still only had access to it within the agency. And then sometime later in the 90s, they took that database online, made a user interface that you can go to. So if you'll just search for EPA ADI on Google, the first thing that comes up will be a link to this. It'll come in, you have a page that says, you've got all these little dialog boxes that you pick from. What date range are you looking at? What rules? What kind of rule? What specific rule? Keywords. And that's where you really put in something to narrow down to see whether or not they've ever answered anything regarding your area of concern, okay? And then you hit check, and it'll come back and show you the Boolean logic of what it's put together from your entries there. And if that's right, you say go, and it'll bring back a list of control numbers. So those control numbers uniquely identify every determination that EPA has made over this 30-year period. And there's a lot of them, and a lot of them give you some good stuff. And we'll show you some examples of that as we go through. But that's a huge thing to have and know about and be able to use. All right, as we go through the regs, typically either a proposed reg or a final reg, about a quarter to a third maybe of the actual total written material is the requirements, specific requirements laid out. There's something earlier than that called the preamble. In the way older days, they used to write a full report before they ever started drafting the reg called a background information document. That information now just goes in the preamble. But looking at either one of those, if it's a first proposal, they'll talk something about the research and rationale they used for what they're proposing. If it's a final reg that's being promulgated, they'll talk about the comments they got on the proposal and how they addressed or didn't address those. So that can give you a lot of good information. The other thing you can do is, let's say you're confused about the sampling connection systems rule, and you're subject to it in VV, and you're looking for some clarification. Well, one of the things you can do is say go to Han and read Han. Now, one of the things about HAN is it's the first and to my knowledge, the only rule that's ever been developed by a committee that included people outside of EPA. Usually, EPA has a lead person that's an actual employee of EPA, and then they'll have a contractor that does most of the dog work of writing the rule out under that person's supervision. But the HAN rule, they had EPA staff, they had industry representatives, and they had environmental advocacy representatives all sitting in a big room, and they met like once a month for 2 or 3 years to hash out the HAN rule. And one of the things that came out of that is there's more English used in that rule than in some of these others, which we call the language in most of the rules regulatories. It's pseudo-English, but not quite. So that's a good thing to do. Go look at other rules that have the same requirement in it to see if the wording's any different and clearer. And if you can't find it out from that, you can try to network. If you're a part of a big company that has a number of different plants, maybe subject to the same rule, you can talk to others how they're interpreting it and try to get that information. Or you can reach out to folks like us, and we'll help you talk through that kind of thing as well. All right, so we're going to start with NSPS-VV, and since it was the very first of these rules and kind of set a pattern, there's quite a few things that are gray in it. In fact, the white pages that are in there are probably fewer than the gray pages, I think. And it keeps going. So we're going to deal with each one of those. I'm not going to talk about them because we're going to get to them individually. So we'll start with the granddaddy, the 3% cap on difficult to monitor valves. And for those of you who are really quick, we're going to have acronym soup all day long. So if there's any of these that I don't identify quickly, stick up your hand and ask if you don't recognize it. So here's the language in 42-7 subparagraph H. Any valve that is designated as described in 60.486-F-2 as a difficult to monitor valve is exempt from the requirements of paragraph A, that means A of 482-7, if the owner or operator of the valve demonstrates that the valve cannot be monitored without elevating the monitoring personnel more than 2 meters above a support surface. The process unit within which the valve is located either becomes an affected facility through 60.14 or 60.15, or the owner or operator designates less than 3% of the total number of valves as difficult to monitor. In addition to that, you're going to have to follow a written plan to monitor it at least once a year. So, relatively straightforward, right? It just jumps right out at you what we're talking about here. One of the things that make these rules hard to understand are these embedded numeric paragraph references. These two right here in particular, this is subpart VV of 40 CFR 60. 60.14 and 60.15 are in subpart A. It was developed way before NSPS, but they're still referring back there. So the first thing we got to do to try to understand this at all is go look up all of these numeric references and figure out what they're talking about. So if you trace 60.14 and subpart A back, that's the modification and the rules about what is involved in causing a modification that would trigger NSPS. 60.15 is the reconstruction section. So in a general way, not specific to LDAR, but just in general for all new source performance standards, this tells you what modification is and reconstruction is, and tells you something about the compliance times and a lot of other stuff. So there's some good information in there. They're worth reading. So you could restate that other part as the process unit must become subject to NSPS through modification or reconstruction, or else limit DTM valves to 3% of total valves. Okay, makes some sense. Starting to make some sense. But, you know, nobody in here said anything about being a lawyer. Are there any lawyers in here? Okay. If you're hiding the fact that you're a lawyer, don't be offended by the things I'll say about you. But, I mean, the world would be just so much easier if it wasn't filled with lawyers. So, if we think back to how could you get into become subject to a new source performance standard other than modification and reconstruction? When the rule was written in 1981, there was only one other way to get in, and that was to build a new plant. The actual, like the name implies, a new source has come in, and it would be in the rule. So it seems once you get those two sections translated that it was really meant for new construction. Okay? But since that time, EPA's written a lot of other LDAR rules, dozens. And they looked at NSPS VV and said, we've already created this masterpiece. Why should we write this same language over and over again? So they went and wrote G, and they wrote the applicability for it, a few definitions that were different, some testing protocols, light liquid, defined a little bit differently than it was for the chemical facilities. And then besides that, they said, you know, go comply with 42-1 through 10. So now, this could have been a unit that came into G through modification or reconstruction, but it didn't come to VV that way. And the lawyers look at this literal language saying, I don't know whether we can take on the liability of it. We're going to have to go ahead and put that 3% cap on all of these things that have any NSPS coverage here. And then to make it worse, we started having consent decrees negotiated and written, and a lot of those will have a, say, blanket coverage of NSPS required as one of the line items in there. So there's another way you can get in that's not modification, it's not reconstruction, but it's not new plant construction either. So quite a few little things. Well, MACT-CC is another one, the refinery MACT. All right, looking at some of the background stuff to see what we can find. Some of this doesn't really tell you a whole lot, but it tells you what EPA was thinking in 1979 and 80 when they were trying to develop this. It said some valves are difficult to monitor because access is restricted. Difficult valves can be eliminated in new process units, but they can't for existing ones. So between this time of proposal and promulgation, they said, well, maybe they can't really be eliminated, but they can be limited as to how many there are. People came back and I'm sure said, we need some design flexibility to not put everything on the ground or a platform. That's just going to double the cost of a new unit or whatever if we have to do that, and that would be too much to make the difference between monitoring once a year and 4 times a year on a valve. So they said, okay, well, we'll allow you some, but only 3%. Okay, but you can see clearly they were distinguishing between new units and other units here. Okay, here's another one in the background stuff. This one doesn't say too much about it, but it's interesting. Valves which are difficult to monitor are defined as valves which require safely elevating monitoring personnel by more than 2 meters. This means that ladders might be required, but scaffolds would not. Well, that's certainly one they backed off of too. There are plants that are represented in this room today that spend $1 million a year on scaffolding for DTM LDAR, primarily out in the interconnecting units and the flare runs. So this went by the wayside, but it's certainly an interesting piece that we ran across. Well, why would EPA just single out new units for a cap? I mean, if you shouldn't have that many difficulties, why not cap them for all kinds of units, right? It's the difference between design for that limitation versus retrofit. And the whole idea of new source performance standards was that when you design a new unit, no matter what kind of emission control you're trying to build into it, you have more flexibility to get that done than if you retrofit the control to the unit. Now, some kinds of controls don't really do that as much. If it's an end-of-pipe type thing, that you can run something that you were venting to the atmosphere through a carbon absorber, through an incinerator, something like that, it probably, the cost to design it versus add it on may not be that different. And actually, most of LDAR is like that. It's a work practice that we have to do, and the work practice is not any less expensive for a new unit than it is for an existing unit. But this is one of the places where new versus existing makes a big difference, because you got an existing unit out there. Some of those built World War II era are still in use, and it's not unusual to see 15 to 20% of total valves that are up in the rack with chain wheels or whatever hanging off the sides of columns that are genuinely difficult to monitor, very difficult to monitor in some cases. If you had to limit those to 3%, you're either going to have to reroute piping, build new platforms around various places, lots of various places, to access them, or what actually happens in most of these cases, you're going to force your LDAR people to go into those elevated areas with fall arrest systems and all the rest on a quarterly basis. So what people do when they have to comply after something's built is they'll take the least difficult and keep working through that hierarchy until they reach the 3% cap if they have to do it. But that's putting people into some danger, some jeopardy, a lot more often than they ought to have to do it. And it's a lot more expensive than you should have to do it. So the difference between designing it into a new program and retrofitting it is a big deal. Han is somewhat better on it. It says process unit within which the valve is located is an existing source, or the owner-operator designates less than 3%. So that's fairly straightforward. They didn't get into the numbers. They didn't get into modification and reconstruction. Those really don't apply too much on a MACT unit anyway. But it's pretty clear here it was existing versus new. Okay? So that gives us something more to boost our confidence. So some conclusions on this. It has been literally interpreted to mean anything that didn't specifically come in via 60.14 and 1.5 for modification and reconstruction. Time written, there was only one way to do that, and that was to build a new unit. But since then, we've got a lot of other things. And we still see a number of plants around the country that just blanket everything to 3%. Okay? It's one of those ultra compliance assurance, I guess, things. But the EPA guys have at least person to person have verified, yeah, you're right, that's the way it should be. But they're not going to do a clarification until somebody actually formally writes a letter requesting it. It hasn't happened yet. See, Chris, do we have we saw something fairly new on this that I think added some weight to that as well. I'll see if I can pull that up and get it for you at lunch. But this came to our attention after we had to submit the final slides for this. That's why it's not in here, but I'll pull it up over lunch. All right. All right. Next one. DOR, delay of repair. Okay? AKA license to leak. It's like what I like to tell people in the plants. Sounds like delay of repair, that sounds like a very reasonable thing. A license to leak, boy, that kind of gets scary. Helps with your leadership team to get them thinking about it in a different way. But in the days when people had a delay of repair form, where it would have like blanks for the unit number, the unit name or number, maybe a sub area, and then they would just have reason, and they'd have like 4 lines lined off where somebody could write in free form whatever they wanted to do. We used to see over and over spare parts are needed and we couldn't get them in within the 15 days. They put it on delay of repair. Makes sense. Makes perfect sense. And there's even something in VV that talks about spare parts in the delay of repair section. So it seems kind of right, huh? But here's the language where it actually talks about spare parts. 42-9E says a delay of repair beyond a process unit shutdown will be allowed for a valve if valve assembly replacement is necessary during the process unit shutdown, valve assembly supplies have been depleted, and valve assembly supplies had been sufficiently stocked before the supplies were depleted. Delay of repair beyond the next process unit shutdown will not be allowed unless the next process unit shutdown occurs sooner than 6 months after the first process unit shutdown. That's all English. We didn't have any of the numeric things stuck into it. But boy, that's some of the most awkward English you could probably put together. First off, if supplies were sufficiently stocked, how'd they get depleted? Well, I mean, I know the answer, but I'm being a devil's advocate with that. You come into one of these big turnaround operations, and you have planned maintenance that's going to take place, and you have inspection going on. And a lot of times the inspection will cause new work orders to be written and added. So you may have had enough to take care of all that was planned, but then you find emergency issues as you start inspecting equipment, and so maybe that depletes this stockpile we thought we had enough of. But it's, I mean, how would you determine any of that? How would you document your sufficiency before and not after, and why? So it's kind of a nightmare that you never want to get into. But what this is saying is, once something is on delay of repair, that you can get away one time if it's because you ran out of parts with not repairing it at the next process unit shutdown. And you can even get away with it a second time based on this last sentence, only I haven't ever found any 2 people that agreed on what that last sentence means. Which is the next and which is the first and who's on second, and you know, by the time you get past that second one, I think I'm reading it to say, all right, you let it go through the first one. That's clear. You're allowed to if you meet this assembly thing. Beyond that, it's not sure there where the next one is. The second or the third has to be within 6 months of the first one, as far as I can see. So I would say never try to go through 2 shutdowns without repairing a delay of repair, because I have no idea whether you'd be within the rule or not based on this language. But the main thing there is, don't use that as a reason to put something on delay of repair in the first place. Now, you would think that if it's sufficient justification to let you not repair it during a shutdown, that it would be a sufficient justification to allow you to put it on in the first place. But there is a specific list of 4 items that allow you to put things on delay of repair, and one of them is not spare parts. It should be, probably should be. But the 4 items that you are allowed to do is if it's technically infeasible without a process unit shutdown, then you can put any kind of component on for any length of time to that shutdown at this point in time. EPA is trying to rein that in a little bit. When they wrote the uniform standards, they said up to 5 years, but that's not come to be finalized and probably never will. The second one is if you have isolated it from VOC service for BV or max HAP service if you're under one of the MAC rules or NESHAP rules. Maximum Achievable Control Technology, NESHAP, National Emission Standards for Hazardous Air Pollutants. HAPS is hazardous air pollutants. So got a few of those acronyms I have failed to find. So anyway, don't use it for the original. Put those 4 allowed reasons on your form with a checkbox. And then if you want a few lines to elaborate on why it's technically infeasible or how you've isolated it from service and so forth, that's good. Before we leave the isolated from service, how many of you continue to monitor your delay of repair components that are isolated from service? I see some low hands. Yeah. What do you do when you start to get higher readings on them? Has it ever come up?
Yeah.
Yeah?
It's not technically isolated.
Yeah.
Start looking at isolations.
One of the things operations guys, Bo, like to do is say, okay, we blocked in the suction and discharge valves on this thing, and we drained it. It's isolated. Okay. When you come back and you monitor it and you get 50,000 ppm on that isolated component, it's no longer isolated. Okay? I mean, that's pretty clear. So what do you do then? You've already got a delay of repair that you've based on it being isolated. Well, if you're leaking through one of the valves that isolates it, then it becomes technically infeasible without a shutdown. Because even if you wanted to pull that pump out and repair it, let's say it's a pump, that's where it happens the most, you couldn't isolate it to do that safely. So basically you have to go in and change your DOR documentation reason from isolated to technically infeasible without a shutdown. The key is to do that as soon as you start getting elevated readings. So if you get 50 ppm, should you do it? Probably not, but if you reach a leak definition for that component, you probably should. So
Now, the way that you asked that question was, how many of you go back and re-monitor that component?
yeah.
You have that option not to.
You know, we always did. If you're under a consent decree, they specifically say you have to continue monitoring at the normal frequency for that component. In the changes to VV in 2007, they put a new paragraph at the end of delay of repair that allows you to take something off of delay of repair based on 2 successive non-leak readings. And it said actually 2 successive monthly non-leak readings, which then takes you back to 42-7 that says when a leak is detected, you know, then you've got 515 to repair it or put it on delay of repair. But there's also a thing in there that says you'll go to monthly monitoring until you have 2 successive non-leak readings. And so it can be interpreted that means delay repair items have to continue monthly monitoring. A lot of the people under their refinery consent decrees, the normal valve rate is quarterly. And so they're doing quarterly monitoring on them. To me, if you have 2 consecutive readings, whether it's monthly or quarterly, it still would allow you to activate that and take it off delay or repair if you wish to. But there's no doubt that for the first 35 years under VV and Triple G and Triple K, that people quit monitoring as soon as they put something on delay or repair. And to this day, I've not heard of anybody getting an NOV for failing to continue monitoring unless it's required under a consent decree. Anybody had that happen to them or heard of anyone getting a NOV for not monitoring a delay or repair component? I haven't either. All right. Initial monitoring for valves. Yes, sir?
What would you consider, say you put the component on isolation DOR.
Yep.
Which reading would you consider, say you take a reading to prove that it is isolated. What reading would you consider proving it isolated? Background reading or below leak depth?
Well, I mean, you could have it isolated and drained and emptied. There still may be some residue in there. So I would say early on, you wouldn't have to be a literally background reading.
Wouldn't you go to the fact that it's in service, the definition of in service? That's what means it's isolated to me.
That would be 10%, which would be 100,000. So that's going to be well over a leak definition. So I don't think we could go that way because we're measuring only what's leaking out, not the interior concentration. Now, if you're going in a removed plug hole and actually reading the interior gas and not the leak, then maybe 10%, would be the appropriate point for that, to say that you're under the applicability of the rule. But if you're measuring leakage at the seams, of normal leakage, potential leakage seams on a component, I would think leak definition. But you wouldn't necessarily expect them to go to absolute zero, even after steaming and stuff. There's always a little residual.
And second question, because I don't see it anywhere really, is that reading, do we have to have a reading?
No. Not unless...
All you have to do is have documentation showing that this component is isolated.
Yeah. Unless, your consent decree, some of your sites' consent decree, where you used to be, has a consent decree that says you have to continue monitoring. So you're going to get a leak perimeter check. And so if you start to get it there, then you're going to say, the isolation has failed. And the key is if you can get your operations to quit just using a closed valve and go to a blind or whatnot, then that will take care of most of your problems.
That is a tricky area because if you isolate, you come back and monitor it. If you have good isolation on that valve, you're going to have 2 consecutive months worth of reading if you do it every. So basically, I have to get that in order to be able to.
It would still be fine to do that as long as you're keeping it isolated and then repair it before you return it to service. But then it gets tricky. We'll get onto this in a little bit as to how you verify repair. Because repair is not just the act, it's the act plus getting a reading that shows it's below leak definition. We'll get on.
I think from here on out, we can pretty much say that the guidance that you're giving us is good with this caveat, unless you're in a consent.
Well, yeah, there are several different specific things in consent decrees that don't occur in the rules. And monitoring DORs is one of those. Okay. In the good old days, there was a 180-day compliance time listed in the NSPS VV and all the other things that refer back to it that said when you build a new unit or an existing unit becomes applicable to this rule, you have 180 days from that point to bring it into compliance. And once it was already subject to the rule, if you added something, there was no other guidance different than that, so we interpreted that we had 180 days to pick up new components added, which the ones that are adding a pump, you're going to know about it for the most part. Maybe a little portable injector pump or something might escape your knowledge, but a pump is a big addition to a unit in most cases. It's the valves. If you have connector monitoring requirements at your facility, even tracking those would be crazier to go with it, and particularly tubing stuff on instrumentation. But so that was the way things were. Then with the changes in 2006 and 7, they added an expectation for 30 days. And the one thing that's the gray area part of that, unfortunately, the 30-day to tag and monitor a new component added to an already applicable unit is very clear that that's what they expect you to do. Which, as long as you know it's there, not a big deal. We'll be talking more about MOC and other things, but the trick on that one can be finding out when it actually goes in. Because some of those MOCs get written and approved, and then they sit around for months and months or even years sometimes before it goes in. And you can get tired of checking, and then the one time you finally get out there and it's been a couple months since you checked last time and it's in now, and you don't know how long. So those are the things to watch out for. But the funny piece in this says that a valve begins operation gas vapor light liquid surface after the initial startup date for the process unit must be monitored according to these paragraphs, except for a valve that replaces a leaking valve and accepted in paragraphs F, G, and H, which is the unsafe, difficult, and no detectable emissions, I guess. And 42, the general standards, and the 2 skip period provisions. A lot of translating there. There's this part here. It says, except for a valve that replaces a leaking valve. Does that mean that you're not expected to meet the 30 days on a replacement in kind? Because people have read this and made that assumption. And it's one that we would dearly like to assume, because MOC, which was written under a safety program, process safety management, the one thing you don't have to file a change form for is replacement in kind. And yet, if we've got a valve that was tagged and now it's gone and there's a new valve in its place, we're not going to find out through MOC that happened. But we need to know if we're expected to monitor within 30 days. Because you might work your way out to a quarterly or semi-annual or even annual monitoring period on the rest of the valves in the unit. So you may not be there within 30 days of when that thing goes in to see that you've got a new valve. So how do you find out about it? It would be really nice if this didn't apply to replacement in kind. So, monitor the valve is in paragraph A1. The valve must be monitored first time within 30 days of its startup period. What's startup period? That's not defined in the rule. If the valve's in a process unit or monitor, well, this is if you're in a skip period, NSPS skip periods are highly frowned on by EPA these days. Not many people using them. Anybody in here using an NSPS skip period? You are, sir? Yeah. Well, if you get to a consent decree, they'll probably force you into quarterly or do what they call a sustainable skip period. They've written a few that allowed that. which says you have periodic audits you have to do under the consent decree, and whatever leak percent they get will determine your forward practice, your leak frequency. So if you've been underfinding your own leaks and an audit says it's much higher, then you're going to have to jump back to monthly or quarterly or something else. But this is just gives you a chance there. You either have the choice of doing it within 30 days, or if you can just assume that new valve leaks and that won't put you over the 2% leakers in that unit, then you can wait either 90 days or till the next regular monitoring on that unit. The preambles, where we get some information here. Initial monitoring is for pumps and valves that come into VOC service through a process expansion or replacement not associated with a repair, i.e. such as preventive maintenance. These pumps and valves may be newly purchased or equipment that was in service elsewhere and moved. Newly purchased, rebuilt, repaired, remanufactured valve installed to repair a leaking pump or valve is not subject to the initial monitoring requirements. Instead, the pump or valve should be monitored to verify that there is no longer a leak as required by the definition of repaired, and may be subsequently monitored according to the schedule applied to that previously leaking valve or pump. So, if it's a replacement in kind that was to repair a leak, then it doesn't have to follow the initial monthly, but it has to follow 482-7C that says when a leak is detected, you'll go to monthly monitoring until you have 2 consecutives. So there's no change. I don't even know why they put the exemption or exception in there, because you're in the same position of 30 days, right? And all it's done is get people confused again. So leak repairs, you still have to do it. Yeah, the alternatives, not so much. All right. This is one that came up in enforcement initially. Actually, down in this region, Region 6, I think was the first area it popped up. We had people out from the agencies, both the EPA region and the states, doing some comparative monitoring. So that's a kind of a new thing from the late 90s forward. And when they come to a valve that had a pump, plug or a cap on it, they'd go ahead and monitor the plug or cap too. And they started noticing that, boy, these things leak pretty often. That shouldn't be. So they went back to the open-ended line standards, and they started looking here for ways that they could say that it's not okay for that thing to be leaking. And they came across the second entry here. The cap, blind flange plug, or second valve shall seal the open end at all times except during operations requiring process fluid flow. So if you're draining or sampling, whatever, venting, it's okay. But sitting there with the plug or cap or blind or whatever in place, you're supposed to seal it. And so they used that as the justification to write NOVs for open enclosure devices, as EPA started liking to call them, that have a reading above, say, the valve leak definition, 500. Most states, most consent decrees and things moving down there. Now, what does it mean by seal? If you go to the dictionary, there's more than 24 entries for seal, including the cute little marine mammal that bounces the beach balls around, that cute little emblem on the front of the podium when the president speaks is a seal. The old things they used to do in the romantic novels where they'd put red wax on an envelope and stamp it with their family crest. Those are all seals. There are some that say it means to basically close an opening. And then there are modifiers, like to hermetically seal something means to seal it in a way that's like airtight. Okay? You need Johnny Carson folks in here with hermetically sealed and verified by Funk and Wagnall or something like this that he and his sidekick used to always talk about. But they're taking it literally and saying that seal means less than a leak definition around the potential leak areas, those threads. And we had in the uniform standards a proposal to say that any open-end closure device with a reading where you could monitor it and get a reading of 500 ppm or higher was an immediate deviation. As I mentioned earlier, the uniform standards are sunk under about 100,000 pages of comments and will probably never emerge. Refinery sector rule went out for comments last fall, and this 500 ppm as a deviation showed up in that again. I'm sure there were a ton of comments on that. Hopefully that won't be promulgated with that in there, but it's one that looks like EPA is going to keep plugging until they get it through. That's what we do here in Austin. They've been trying to get light rail mass transit in here around, and so it fails and it fails, and they just put on every bond election it comes back, and that's what EPA seems to be doing with this. They're going to keep plugging till people wear down and they eventually get it be a rule. And to me, that's not an appropriate rule because it can't be complied with. No matter how ardently you try, if you're already in a deviation when you find that there's a problem, you can't comply with that kind of rule, okay? We know that threaded connectors are the most troublesome to seal and keep that way. And EPA seems to think that the reason we have so many leaking is that operators just come on and hand tighten them on, or maybe they use a pliers but they don't put any tape or dope on it to help seal the threads. But you know, that's not the case necessarily. You can do all of that perfectly. You can tape and dope it and put it on with a torque wrench, and if it's sitting on a line that has thermal stresses, gets hot and cold, if it's got vibration on that line, corrosion, both internal, external, all of those things over a period of months, if not a period of years, can cause that thing to leak. And you'll never know until you monitor it. And when you monitor it and find it above, you're already out. So if they put some response time, like in the pressure relief device stuff, 500 ppm, no detectable emissions, is the rule on your pressure relief valves, and you have to come out after a relief and it reseats to see that it's back under that. If it's not, you have 5 days to work it and return it before it becomes a deviation. So you need that. Maybe a relief valve, you know, it usually takes a crane to get out and lift one off, put the other one on. A little more complex device than a plug. So maybe we don't need 5 days. Maybe we need 5 hours, 5 minutes, something. And we could stop the vast majority of them and have a half a chance to comply. But the way they're putting it in now, you have absolutely no chance. Consistently. I mean, you can comply 90% or 93% or 97% depending on the facility. What time are we breaking, Chris? Look that up for me, please. So we talked through most of this kind of stuff. Here's a special deal on open-ended lines that comes up a lot. Besides the cap, plug, and blind, which are an actual closure, you're also allowed to comply by closing 2 block valves in a row before the opening to the atmosphere. And it specifically says that when you do that, that you're supposed to close the upstream valve first and then the downstream valve. Why would that be? Why would EPA care what order you open and close these things? If you close the downstream one first and then the upstream, you're going to trap product and pressure between those two valves. That means the terminal valve is now an open end, because one of the definitions of an open end is a single valve seat between the process and the atmosphere. So if you got process trapped between the valves, you don't have an open end closure. It's not a compliant system. Okay? How do you get your operators to do that? How do you tell they did it? Well, unless you're standing there when they close them, I don't think there is a way to tell. So EPA would probably, based on like this 500 ppm thing, would say, all right, if we come along and we measure and we get some kind of a reading here, then obviously you didn't close them right. No, not necessarily. The reason we have open-end line rules is that leakage past the seat of a valve along the line is common. That's why we have problems isolating these pumps and maintaining the isolation. We know valve seats leak down the line. And so some of the time. So that's why we have it. And if that's we know it's going to happen to a certain extent, what you're doing is buying a little time by having the upstream one closed, and slowly, as that leaks through, you'll get a little bit of process, eventually a little bit of pressure, and may eventually have a leak, but you're going to buy some time, right? One of the things that's really hard to think of, you think of how do you limit emissions by having an open-end line controlled? Okay? You're going to take what might have been leaking past that seat and you're going to stop it with something else, a plug or a cap or a blind or another valve, okay? But then what do we use these for? Sampling, draining, venting. So it depends how often you use that valve. Let's say it's a sample point that you take twice a day, 3 times a day. All right, you're going to close that off, but whatever leaks past that valve is going to be trapped between the plug and the valve seat. And when you open it to sample, so we didn't have it continuously leaking over that 8-hour period. We just trapped all the leakage over 8 hours and let it out. Okay, maybe it's something that you only plug you pull off when you're going to drain water down. Well, yeah, that probably wouldn't even be in service. But anyway, something to use every week. Okay, and again, you're going to have leakage past it. It's going to be trapped in the piping or space between the two. And as soon as you take it off, you let it all out. The only time you begin to reduce emissions by closing an open end is if you keep that plug or cap or blind in place long enough that the leakage would reach full process pressure, and that would be still a valid second place to keep it from going to the atmosphere after that. So how long would it take to reach process pressure? If you've got a plug screwed right into the body of a valve, there's probably just a tiny little chamber in there that might do that fairly quick. But often we've got a 4-inch or 6-inch spool piece sticking out and then maybe a cap instead of a plug or whatever. So I don't know. If you look at the emission Bible, the protocol for equipment leaks emissions estimating, it says the effectiveness of open-ended line control is 100%. And that's one of the things EPA used as, in addition to the definition of seal, as a validation that finding a leak definition is an NOV. Because the expectation would be that they were 100% emission reduction. That's, from what we've just been discussing, that's obviously not right. I didn't realize it at the time, but anyway. So be careful with these double blocks. There's specific situations where even if you close the upstream valve first, you may not be compliant. We see a lot of these where maybe you've got a drain valve off the bottom of a control loop. And it's been set up to be a sample point. So the operator got to get down there. Maybe that valve's 6 inches off the ground. He's got to tilt in his bottle to get his sample. He's down on his hands and knees working. But this is ergonomically a mess. I'm spilling more than I should because I can't get the thing. So he goes and he gets him a reducer and goes down to 1/2 inch or 1/4 inch tubing size, runs it over. So I'm going to be green. Let's take it over here by this drain hub, include if there's any splashing or spillage, it'll go down the drain and up waist high. So I can have a gate valve there, and I'll put a second ball valve here, and I can ergonomically, without bending and stooping, fill this thing up, less spillage, the whole 9 yards. I'm doing a good thing, right? Except if you're saying you're controlling that by a double block valve, one here, one there, if you've got this kind of change of elevation, it's only going to free drain up to that point as you're taking your sample or venting or whatever you're doing. And so closing this and then closing that still traps process in all of that loop. So those are a much more subtle version that could get you in trouble. So some definitions we already talked about, the standards. Second valve shall seal at all times. Yes?
The upstream block valve, is there any guidance on that as to how near or upstream has to be?
There's nothing in the rules. Now, we occasionally will put in what we call a supplemental observation when we're in our audits. So say you've got, let's say it's a sample point, and you've got a 1/4 turn, a small valve at the sample point, and then the next block is 10 feet up in the air and 30 feet down the rack. Okay? And as you get there, the sample point's closed, and the one up in the rack is closed. You can say, okay, as I sit here looking at this, it's double blocked, so I'm not going to write you up for non-compliance, but tell me how you would operate this to where you're going to go up there in the rack and block this thing out and then allow all that line to drain and then close the other valve. So it's one that, you know, go ahead and spend the $30 for a second 1/4 turn at the terminus and put them close enough together where it's reasonably appropriate that an operator would do it near 100% of the time correctly. So it's not a good idea to have them far apart, but I don't think there's anything in the rules that would say it's not allowed.
Kind of a common sense issue.
Nothing less common than common sense, right? And especially when it comes to regulators and enforcement people. So vertical legs, anything that traps material between the two. Process fluid can be liquid or vapor, so it's not only where the liquid is. Block and bleed systems, any of you use those? Got a block valve in line with each other and then a bleeder in between. If you want to have total isolation, you block both of those in, recognizing either one of those could leak past. You open the bleeder, and theoretically anything that leaks past one or the other will go out the bleeder without getting to the other component, cross-contaminating, or particularly if you have materials that could, you know, runaway reaction or pyrophoric or something like this that might cause big problems. You can use those. And you are allowed, while both of the other valves are closed, to keep that bleeder open as part of a block and bleed system. So you can run that way. But you do have to close it as soon as you open either valve. Okay? Now we get to a special version of that. I don't know if there's anything right here. We'll see it mainly in the components and low leak later on. But 12 Twin seal valves. Anybody in here use twin seals? I know a lot of you do, particularly out in the tank farms. That's a block and a bleed built into a single valve. It's kind of like a plug, and it's got a big quarter-turn mechanism, but it's got a full seat seal on either side and then a body bleeder. Now they come in several configurations or optional configurations. At the very least, they come with a thermal relief valve, because when that thing's open and then you close it, you trap it liquid full when you do that. If you did that in the cold weather or at the cold time of the night, you can actually expand enough to potentially crack the body of the valve, but they put out a blowout plug that's the weakest point in the bottom. So at the worst, then it would blow out, you replace that plug, and you've lost whatever was in the center part of your valve. But so you've got that there, but you can also have a manual bleed valve, and that's what you would open if you're going to set it up to be a double block and bleed system. And the way those are wired, when it's not closed, when it's open, that manual bleed, the closure pieces come up by the walls, but they don't seal off against the walls. So there's process fluid running behind them to the wall and up against that valve seat. So when you're running that valve open, that bleeder is a potential open-ended line. So that's one to watch out for. Engineering. Second valve, just more examples of where that's talked about, trapping fluid. Got that. All right, so you've seen the whole open-ended line thing is pretty complicated. Getting it right, enforcing it, all of these are pretty difficult things to keep straight. Now for something a whole lot easier. Check valves. That's a valve, right? Applies to 42-7. How many of you, let's do the hands. How many of you treat your check valves just like any other valve, monitor at the same frequency as all your valves? Okay. You what?
Depends on how it's configured.
Okay. How many of you treat your check valves as a no detectable emissions valve and only monitor them annually? No takers on no detectable? How many of you say they're not a valve at all? If anything, they're more like a connector? Okay. Well, this is one where we do have an applicability determination. Control number 01025. Somebody wrote in and said, is an inline check valve subject to the requirements of 42-7, or is it considered a no detectable emissions valve? EPA replied, since an inline check valve is enclosed within the process piping for directional control and do not have the potential for fugitive emissions, which are regulated by the standard, they may be considered exempt from subpart VV regulation as valves. Then they didn't tell you what it is. Yeah, there are some that actually do have a test lever, I think they're called, or a hinge cover, nut, or bolt, and we'll see some of those when we go through the components. So there's a few types maybe I would consider a valve, but the determination we've got is pretty blatant that you don't have to regulate them as a valve. And he asked, or should it be an NDE? And he said no to that too. Didn't go on and take the next logical step and say what they should be considered. And you know, all of them have that kind of bolted, gasketed inspection and maintenance port on the top, or most of them, I should say. And that is kind of connector-like, and that's why probably the majority of the hands I saw go up kind of treat these as connectors, which in a refinery means it goes into just if you see here a smell, AVO detection, then you come check it. Otherwise, no scheduled monitoring or maintenance. Early stuff talked about the lack of a stem penetration, that being the characteristic emission point of the valve. All right, conclusions are pretty straightforward. All right, this was an interesting one. The original 42-7 for valves said you start off at monthly. Any valve that's not have a leak detected for 2 successive months may be monitored the first month of every quarter, beginning the next quarter, until a leak is detected. Okay? They wrote this in 1981 when there were virtually no units under LDAR. And they were thinking, you know, plants will have a sprinkling of these units come subject to this over the years, but didn't think too much about how it might create a situation where your labor requirements would be very unbalanced. Okay? If we had to literally do all of our NSPS valve monitoring in January, April, July, and October, we'd have to bring on extra staff in those months and then let them go for 2 months while we did the rest of the annual and quarterly stuff. Okay? Well, yeah, that's the quarterly valves, the bulk of the quarterly stuff there. So that would be an unworkable deal. People have worked around it by dividing up their units into 3 groups and assigning different quarter definitions for their 3 groups. I saw people that specifically had this all written out in their LDAR plan. Very well done. There's actually a hidden thing that makes this make sense, and that's the definition of quarter. Quarter, and this is the only period of time that is defined. There's not a definition for monthly or month or semi-annual or annual, only for quarter. It says quarter means the 3-month period. The first quarter concludes on the last day of the full month with a full moon during the 180 days following initial startup. Oh, I think I might have added something there. But, so what does that mean? If you started up a unit on February, what's today, 16th? Okay. Then somewhere in, say, August 16th is your 180 days, not counting the differences in the month lengths. We could calculate it exactly, but somewhere in the middle of August would be the end of it. So that would mean the quarter ending at the end of July. July would be the last full month within your 180 days, because we only have a part of August. So then we'd go July, June, May is the start of the first quarter for that unit. Okay? Y'all have all got the dates of construction for all of your units, and you're being sure to run your quarters this way, right? Well, you know, had we sort of noticed this and realized it 30, 40 years ago, I guess we could have run them that way. But what we actually do is just load balance. You do a third of them in the first month of the quarter, another third in the second month, and another third in the third month, and you try to stay with that schedule. When you have major outages for repairs and maintenance, then you work around it, shift it for a while, but you try to come back to your same month of the quarter that you start on. So we're getting there. In the 2006 stuff, EPA responded. We had indicated that there's some confusion on this issue. So they said, well, as an alternative to monitoring all the months in the first, all of the valves in the first month of a quarter, you could subdivide your unit into 2 or 3 subgroups and do a third of the unit in the first month, and a third of the unit in the second month, and a third unit in the third month. Well, that's real efficient, isn't it? You tramp out there, you get your authorization to work, You got maybe one or two guys working on it, people working on it. There's a lot of gals involved in this work area now. And so they get to a third of the way through, and maybe that's on the middle of the second day. They got to go sign out of their permit, go back, turn in their data logger, get that all downloaded, get it signed to a new unit, go someplace else, instead of just staying there and working on through and finishing it by the third day. Doesn't make much sense. It's not efficient. But at least it gives us a hint that, EPA is not feeling it's a concrete deal that you have to have everything done in the first month of the quarter. So that's good. Now this one. We're going to talk about common problems on Thursday, I guess. This is one that we see coming up more than almost anything else. And it says, okay, unit begins monthly monitoring, you get 2 consecutives, an individual component can move to quarterly after 2 consecutive non-leaks, right? But then it says if a leak is detected, the valve shall be monitored monthly until a leak is not detected for 2 successive months. It does not say after the leak is repaired, a valve will be monitored until it is monthly, until it hits 2 consecutive non-leaks. So if they'd said that, this would have been a whole lot easier. It would have made sense. And this is where the DOR monitoring also comes in. It doesn't seem quite explicit that that's what they meant, but that's what the language says. It gets a little sticky because, let's say you find a leak next week on February 24th, and you get your first attempt at repair done, and it's not successful on the 25th, and then you maybe make another attempt before the end of the month, but it's not successful either. And then around the 3rd of March, you go in and you do something and you get it below leak definition. So it's successfully repaired now, okay? Since that's in a different month than the leak was detected, does that count as your first monthly successive monitoring event? Almost every database that's out there right now treats it that way because there's not a specific difference between scheduled monitoring and repair verification monitoring. All right? I went back and researched this one. This is one of the more recently added ones to the bunch, thinking I would certainly find information that would say that EPA expected that there be a difference between these 2 types of monitoring. Ooh, let's see. Okay, we've probably already talked about these. That's another one I didn't talk about, is like you've gone off on skip periods. Even if we're beyond how we determine which 2 months you have to follow up in, do you have to follow up at all? I have one entire corporation that's given me a letter from their lawyers that their interpretation is that once you go to 42-3-2, nobody uses 3-1 that I know of, that it says it exempts you from 42-7. Mm-hmm. And I would say definitely the majority of people doing these do that. Because there's other stuff, I mean, the repair requirements aren't repeated again in the alternate monitoring standard. So the leak definition, the 5-day first attempt, 15-day completion, and so forth, that's all over in 42-7. So you're not completely exempted from that. So I don't quite buy it, but there is enough of a dialogue there that I know of one whole corporation, like I say, that's got it in writing internally, and they follow that at all of their plants. And I know others where individual plants within circuits do it, but the rest of the plants don't. But that is one that's kind of gray. But the main one is the months. I think most of us think about repair verification different from scheduled monitoring. But there's not a lot that I can find in the rule language or the BIDs and that kind of thing to support it. I can tell you this, as you read that the background information document for NSPSVV, they talk about the reason that they put this in there is to detect and repair an early recurrence of the leak. One of the things we found in that 70s and early 80s vintage research work is we took a body of valves that we'd found leaks on, they were repaired by the site, and then we would come back several months in a row and recheck things. And I mean, leak frequencies were high at those times anyway. They're around at 10,000 ppm leak definition in those refineries pre-LDAR, we were seeing 10% leak rates. But of the valves that had already leaked once, for the first 3 months, there was an over 20% recurrence of that leak. Probably indicating that maybe the repair was a little slipshod or whatever. It just probably indicates that it was one of the more severe service categories. It was more challenging to the packing, or the packing was pretty well worn out and cracked. And you could get it down for a little while, but you couldn't keep it. Just kept coming back. So it has some language where they talked about that the follow-up monitoring was designed to detect and repair early recurrence of leaks. And here's some of the data they had in here. I apologize, this is small print, but let's look at valves. Vapor service, they were about 10% of the initial leaking. If you went to an annual rate, it would go up to about 20. Quarterly, it was 10, and if you went monthly, 5. Of the ones that leaked, the estimated ones which were found leaking in subsequent inspections, what's the difference here? Estimated leaks are found at subsequent inspection. Okay, so this is from the initial. If you followed it up annually, 20% of them were leaking. And that's not 20% of the total population, it's 20% of the valves that leaked again within the next year. If you came quarterly, it went down to 10. And if you came monthly, it would go down to 5% of the valves leaking. So with 2 monthly monitoring events, they thought that was going to catch and detect, make a more permanent repair on these valves that did find leaks.
Those numbers don't look like they were estimated using the actual data.
I mean, because they're too round? Yeah. Yeah. There was data behind them. I mean, some of these you'll see 2.4 and 1.2 and 0.6 in this subsequent after the first. This is the first reinspection, and then that's the second reinspection. So we got, I don't know why they put them round. There was definitely some data behind it. It's not definitive by any means. So this is why they wanted them done. And if what you were trying to do was stop reoccurrence doesn't happen until the prior leak is repaired, right? So you can kind of infer from this logic that they meant for it to be repaired which at the time the definition was for repair was to take the physical action that caused the leakage to stop such that it was below a leak definition. But it never said that you had to actually monitor and show that it was below the leak definition within the 5 and 15. We got Frank Burgard, I know, is here this week. I don't know if Maurice Pender is going to be here, but they used to have a little show they did almost every year at ISA, arguing back and forth between whether repaired had to include a monitoring event or not. Obviously, if you don't monitor it, if you're going out to the 15th day and you go put a wrench on it and say, okay, we're not going to put it on delay, and then you don't get out to repair it till the 16th or 17th day, if it shows it's repaired, you're good. But if it doesn't, you're already now in a deviation because you didn't put it on delay. So it doesn't make any sense to do it, but until the 2006-07 changes, they changed the definition of repaired to physical action to reduce or eliminate the leak and a monitoring event that shows a below leak definition reading. So now we don't have to worry about that. But it seems you could infer that recurrence would be after the repair, so they were looking for 2 months after that. But there's no other language I can find that differentiates between one kind of monitoring and the other, okay? So at this point, when we find these where they were at this straddle at the end of the month, we'll put it in as a supplemental observation. I won't call it a hard non-compliance issue if they counted that as one of their 2 months. But we'll bring it to their attention that it doesn't seem to be within the intent, although it may be within the letter of the rule. And you might want to consider, tracking this outside your database, because it's very hard for the database to understand that difference. All right, well, this is just what we're actually talking about. There's going to be times that EPA recognizes you're not going to be able to access your unit and get out there when you normally do. Obviously, if you're on a quarterly basis and your unit is out of service for that entire quarter, then you have no opportunity to monitor it. By out of service, I don't mean just not running, I mean purged of product and not in VOC service, okay? If it's down but liquid full, you can go ahead and monitor. That's not the ideal time. You're not going to give it the hardest test for finding leaks, but if that's your only time to access it, you're better to go ahead and get it monitored under those conditions as not producing but liquid full or fluid full than you are to try to skip it. But if you have to shift some things around, good one, Chris, to get some flexibility to work around downtimes, hurricanes, all the other real life things that interfere with our normally precision monitoring schedules, then the general standards 42-1 F3 gives you reasonable intervals. And these reasonable intervals are expressed as the minimum number of days you can have between any two successive monitoring events. You would think they might give you the maximum number of days you could go between any two monitoring events. But why do you think they gave us a minimum number? I don't know if my mic was on, anybody was listening as we were talking up here, but some people figured out on your annual DTM monitoring, particularly things where you had to go to the expense of erecting scaffolds, that you could schedule your 2014 DTM monitoring and put up scaffolds on December 27th and get up there and monitor before the end of the year. Leave your scaffolds up, and on January 2nd, go out and do your 2015 monitoring. So you get 2 years worth of annual DTM monitoring done with one scaffold erection, okay? Pretty good idea, pretty swift idea. And then EPA found out about it, and that's why they put in these reasonable intervals. And so if those are on annual, they're saying they have to be separated by at least 120 days. So they shut down the scaffold scheme. And that's why they conformed them like that. So if it's quarterly, you can't have any two closer together than 30 days, semi-annual 60, and annual 120. They don't give you a reasonable interval for monthly, which is kind of odd. But you can see all of these, the reasonable interval is approximately 1/3 of the total interval. So based on that, that would say that for your pumps or any other monthly work you might have to do, that it would be no less than 10 days between monitoring events. So those can be used to figure out what you can do around these. It's a little harder working with the minimums because let's say you normally monitor in the first month of a quarter and your unit is down until through the second month of the quarter. So now you're going to have to monitor it, pick it up, monitor it in the third month. So what that limits then is you can't go back to the first month, your normal first month monitoring right away, unless it's later in the first month so that you have actually 30 days between each monitoring event on each component. So that's the way it limits you there. In the long term, it limits maximum time too, because you can only carve off 30 days between, and so that would mean maybe 120 would be the longest you could go between any two, and not force another to be less than 30. So, so they're there to be used as appropriate. Huh. Here's my. Yeah.
Now, this just refers to like your routine work, routine life.
Correct.
I mean, it just doesn't take into account special circumstances, turnaround, you're back, the unit's back up, so the last week, so you've got to get in there, get everything monitored, and you have to put, put on DOR, or put it on POS.
Mm-hmm.
And then, but it's in the schedule the next month. Are we, is it okay to go in there like the second week and do the regular schedule time, or should we try to wait till the end of that next month to monitor those components that just came off of turnaround? In other words, how would you regulate or work this, or does it apply to exceptional events?
Well, I think it's meant mainly for exceptional events.
Mainly for exceptional.
Yeah, yeah. Because otherwise, you're going to go ahead and do it as it's normally scheduled, right? So that's just the run-of-the-mill stuff. It's the shutdowns, whether planned or unplanned, and various links that happen during the time you normally monitor that are going to cause you to need to move it, and then the reasonable intervals give you some guide as to how much you can move it within that bit. And the question we were discussing up here before we started talking privately, or when we finished talking privately, was suppose you down all of a quarter and then you come up on the last day. And in this particular case, he had thousands of components on that unit. With startups, we're going to talk about in a minute, you often have a time when non-essential personnel are not allowed on the unit for safety reasons, stability, things like that. So do you have to get that? It will be impossible to get it all in that time unless you're going to import an army of people to get it done. And then it's not going to be done with good quality. So I'm not aware of people getting fined for not completing something on incredibly short deadline like that. Now, if you had 3 days or a week at the end of the period, I think, yeah, they're going to expect you to do it. Otherwise, I would just do it as soon as I could in that next quarter, first month of next quarter, and then from there, using the reasonable intervals, try to get back to my normal schedule position within the quarter. Okay? Is that one? This is an interesting one on we talked about whether repair verification monitoring would be counted as your follow-up. And in the one case here, where if you're saying you're going to monthly monitoring and your leak detection was late in the month, 20 whatever, and then you do the repair verification early the next month, if that's in less than 10 days, which would be the assumed reasonable 1/3 reasonable interval for monthly, then that would not be allowed to be a monthly monitoring happening less than 10 days. So if you detect the leak, let's say the 28th of the month, you repair it on the 2nd of the next month. Although it's in the next month, they're too close together to meet the reasonable interval test for monthly monitoring.
The regs are silent on that minimum file.
Yeah, right. They didn't put the monthly in for whatever reason. But it does kind of suggest that there might be places where the repair verification monitoring might not be considered an acceptable one. So conclusions here. Reg language, again, is not super clear, although it certainly seems to suggest that after a leak is detected, you begin monthly monitoring rather than after repair. The BID is fairly explicit on the fact that early leak reoccurrence was the reason they put in the follow-up monitoring, and that with their data, they're showing that 2 monthlies would find the vast majority of these early recurring leaks, and reasonable intervals might restrict even some of those. So skip periods. A couple of things on those. We were talking about another one during the break. You got 43-1 and 2 in the NSPS. 43-1 is almost never used. This one says you got to keep your valve leak rate under 2%. You got to demonstrate it initially and annually, and got a 10,000 ppm leak definition. And if you should find it over 2%, or if EPA finds it over 2%, it's a deviation. It also says something about monitoring them all within a week, which big unit like you were talking about with 8,000, you'd have to put quite a few people on that to knock it out in 1 week. So this is one that's it's kind of interesting, but few, if any, facilities have used it much. It may be something in fine chemicals where the stuff you're processing is just so low of vapor pressure or so unlikely to leak that you can feel confident it'll never get over 2%, and you might want to do this, but I haven't run across it being used much. The 43-2 used to be used quite a bit. EPA denies it in most of their consent decrees, so it's being used less and less as we go forward. And they definitely prefer the Han style of skip period to this, or performance-based monitoring is probably the better way to talk about Han style, where this one literally is a skip period. So initially, you come into it, you comply with 42-7 until you get the majority of your valves out to quarterly, and then you can elect to go to this 43-2, and after 2 consecutive quarterly leak detection periods at less than 2%, you can go to semi-annual monitoring. Therefore, skipping 1 quarterly monitoring period. That's why the name skip period has come about, although it's not really used, called that in the rule. And then it says, or after 5 consecutive quarterly leak detection periods with less than 2%, annual monitoring is allowed. And that's actually a little different than the way most people do it. Most people go 2 quarters and go to semi. Then if you go a couple more semis under 2, you'd go to annual. But by saying that this has to be 5 consecutive quarterly leak detection periods, it would say if you drop off after 2 to semi, that you can't then move on to annual. I don't know. Everyone that I have ever seen operate one of these did it that way. But the way that says or instead of and, I would have thought if the way we've done it, it would say and after 1 additional or 2 additional semi-annual monitoring periods under 2%, you may go to annual. But they expressed them both on quarterly and put that or in there, which to me suggests that you have to delay your gratification. Don't stop and go to semi. Keep going quarterly until you get out enough to go to annual. Or stop at the semi and not have the chance to get to annual unless you eventually go over 2% and have to go back to the basic 42-7 and work your way back into it. You can reapply after that. The question, the main gray area about this, though, is if you do hit this, and it says you have to go back to 42-7, does that mean you have to go to 100% monthly monitoring for 2 months on all of your valves? And if somebody wrote EPA and asked them to clarify this with an ADI, given the current state of things, I expect they would say, yeah, that's what we want you to do. But reasonably speaking, you've got over 2% that have leaked in the most recent monitoring period. So probably you've got 96, 97% that haven't leaked for 2 consecutive periods. Now, the fact that those were 2 consecutive semi-annuals or 2 consecutive annuals actually makes the probability of that valve leaking anytime soon even lower than if you had 2 consecutive monthlies. If it's been steady over that long a period of time, it's more certain that it won't leak. So why would you pull those in? Without clarification, what we suggest to people is that you follow 482-7, which says that anything that has 2 consecutive non-leak, it actually says 2 monthly non-leak, but again, they were thinking in terms of linear application of these rules. You come in, you have nothing going on, you start monthly, you do 2 months. Those that haven't leaked after 2 months can go to quarterly, or any others that leak after they've gone 2 consecutive months, then they can go up. They never really thought about how you would loop this thing back around. So does it make any sense to do 100% monthly? I don't think it does. Has EPA ever come out and fined anybody for not doing 100% monthly? Not that I've ever heard of. So it's a gray area, and it's a risk management decision on your part. But I really don't think you're spending the effort of your LDAR program in the most efficient way by monitoring something that's been leak-free for 2 semi-annual or 2 annual periods. So you'll have to decide what your risk tolerance is on those things, just like investing or whatever. If it keeps you awake at night, go ahead and send them out there monthly. If it doesn't, then take your chances. So it says you're going to go back, but you can elect it again. So this is just what we've been talking about. 2 successive months.
And that's a by unit, by process consideration.
Yeah, all of the NSPS stuff is meant to be analyzed by unit because they never thought that we'd have blanket coverage. They thought it would be a little checkerboard out there and it would only be realistic to do it on a unit basis. This is an interesting one. In the record keeping section, there's fewer gray areas in that than in the requirements. But here's one. 46-E says the following information pertaining to all equipment subject to the requirements of 42-1 through 10 shall be recorded in logs kept readily accessible. A list of identification numbers for equipment subject to the requirements of this subpart. What's 42-8? Anybody remember? Oh, yeah, I should have covered that up, huh? So it's all your AVO monitoring stuff. Heavy liquids on pumps and valves, any liquid on pressure relief devices, and anything, including gas, on connectors. You have no scheduled monitoring, but if you see, hear, or smell something, you have to go out and do it. So all of your heavy liquid components, all of your connectors, all of your liquid relief valves are subject to the requirements of 42-8. So is this saying you have to have a list of identification numbers for all your heavy liquids, all your connectors, if you have no monitoring requirement? You do have it?
We've elected to tag everything.
Yep.
For EI purposes.
Good. If you've got a reason to do it other than this requirement, we haven't been able to find anything in the ADI or preamble to clarify it. But again, trying to go back to common sense, what makes things work. These heavy liquids, liquid PRDs and connectors really don't become subject to the requirements. And the requirements are to, within 5 days, either monitor it to show whether or not it's a vapor leak, or to repair it to get rid of the sensory indications of a leak within 5 days. So that's really the requirement. So something is not subject to that requirement until you have had an AVO indication reported for it. And so that's the rationale that lets us get by with not having IDs for every heavy liquid. If you're going to have an AVO come into your system, you should assign an ID number to it so that you can document compliance with the 5-day requirements to either monitor or repair it, okay? So that makes sense. Going out and hanging tags or assigning numbers in the database to things that you haven't identified in the field is totally unproductive. So again, the rationale here, some people have done it by tagging, others have done it through the highlighting of their P&IDs. They'll show they are VOC, but they're heavy liquid or whatever. So you could say they're sort of identified that way, but it's not an identification number like the rule says. So really, the way most people do it is to say that it's not subject to the rule till it triggers an AVO inspection. We have a breakout session here, Chris? Yeah. We sometimes do with these things, but with this size of audience, it would be very tough and time-consuming to get that set up. All right. This one is a mill of a hess. If you thought the others were problematic and so forth, this one is a real snarl. So NSPS VV and VBA both have in them this language that says you have 180 days from initial startup to bring all the requirements for leak detection and repair into compliance. All right? Mentioned earlier, that used to be the only time thing we had for it, so even a new piece of equipment in it already covered, we applied that to it. Now we got 30 days for that. VV has the same language. Initial startup is not defined in the new source performance standards. It is in HAN, we'll get to that in a minute. It could be a lot of things. First time it's put into VOC or HAP service. It could also be the first time a new regulation applies to an existing unit. If you go back to 60.14 for modification, it's got the same 180 days to bring an existing unit that modifies into one of these NSPS regulations as a new unit constructed that becomes applicable to it. So it could apply to both new and existing units. The HAN has this definition. Initial startup means the first time a new or reconstructed source begins production. It does not include operations solely for testing equipment. Initial startup does not include subsequent startups following malfunctions or process unit shutdown. So that kind of gives us something, well, it's not in the rule we're talking about, but it gives us some guidance on what EPA thinks initial startup is. Problem with this second sentence. Initial startup does not include operations solely for testing equipment. There have been some questions from commenters and things like that, and EPA has kind of given examples as, let's say you were fired up a heater as part of testing the leak tightness of the tubes inside your heater before you put oil in it. That would be solely for testing. But, you know, many times we fire up these new units and you hope it's going to just come up like a dream and level out and start producing on-spec material from day one and so forth. But often that's not the case. So you didn't necessarily start it up with the pure intent of it just being for testing, but you may run into days, weeks, and even months sometimes of running it off-spec, debugging, working things, and not making any viable product. So does that count as just for testing? I kind of think it should, but that's not the kind of examples that EPA's given us around that language. All right, so regardless of when initial startup is, we've always thought we had 180 days. And just like the thing, wait until the 15th day to make your second repair attempt and then don't monitor it till the 16th, you're really taking a chance if you wait too long during that time period. You can't be a total procrastinator. I don't think anybody thinks it would be the smart thing to do nothing for 179 days and then bring 1,000 people in to tag and monitor your unit on the last day. But there didn't seem to be anything in the rule language to preclude that. You've also got things with annual or even less than annual requirements. Are you supposed to do those all within 6-month period? Or just half of them, or proportional type of deal? Or what would you expect on those? Do you have to have submitted a report? Do you have to do all performance testing? Now that one's pretty clear. I think if you go back to those initial subpart A discussions, all the performance tests have to be completed and reported within that 180-day to show that you're in compliance. The only true performance tests would be NDE monitoring, and if you have a control device that your closed vent system goes to, that's other than a flare, which is it's based on characteristics of the flare rather than an actual test, to show 95% control. So those have to be done. We know that. Let's think about what else, though. So why did they give us so much time? What do we have to do? You've got to get through that startup and unstable period. That could last a while. You've got to mark up all your drawings. You've got to get the people out there on the unit when it's safe to do so. That sometimes can take months. There was one facility that had some famous issues, and they started a contiguous area blackout. If any unit that bordered a unit was having problems, as little as like the speaker that would come on and say if the alarm went off, the speaker would say this is a gas release on such and such. If that speaker was out, the 5 or 6 units that bordered that all allowed no non-essential personnel. So huge portions of a plant could go out for one little malfunction. So access is a pretty big deal. Yeah, we talked a bit about that. Besides that, you had to determine which regulations apply. You say, you had to do that when you permitted it, right? Well, new regulations can be promulgated between the time you made your initial permit application and the time you're constructed. You could have new interpretations of the rules that you were already there. So you've always got to go back and finalize it. You got to mark up your process diagrams. And yeah, you can do that before startup. Those you've got a design set of drawings that you're going to work on. But there's always going to be some slop in that. How many of you ever saw one that came up where the as-built met the design drawings precisely? Almost never. I'm sure it probably has happened somewhere sometime where somebody was cookie cuttering unifiners or whatever, and the 100th one they finally built it exactly the way they intended to. But I've never seen one or been involved with tagging one. So you're always going to have to make a repass to catch those things. And QA reviews, you know, to do this right, it takes a lot of time. Then you're going to have to flag streams. I don't know if everybody has adopted that part. We used to just tag and document. And in more recent years, we've added the flagging stage where you go out and put a piece of surveyor's tape or a label at the start of one stream and at the end of that stream. And then everything between that, you've got all the data for documentation on the beginning and end tags, and then you have everything that's later tagged per the flagging. So you get the flags that got to be developed, they got to be hung in the field, and you got to get them QA'd. Components have got to be tagged, then documented. All that's got to get up into the database, and then you have to QA all of that, get monitoring schedules set, regs applied, and figure out when you're going to monitor each one of these things. You can do a lot of this before startup. But what's the last couple things that happen during that construction period? Sandblasting, painting, still got a lot of scaffolding and stuff up, a lot of overhead work, there's safety issues, and you do hang tags, you can count on probably losing 15, 20% of them during that last couple of weeks before startup. So you're going to have to go out, find those, replace them, and get that all set before you can really start to monitor. All right, we don't need, you know what all these 10 sections of the thing says. But basically, you know, you're going to have to start monitoring your pumps at some point during that. You're going to have to get your compressor seal criteria documented and make sure you meet that, or else designated as for no detectable emissions, and get your initial performance test on that. You're going to have to get your pressure relief devices and gas vapor service tagged and know when you're going to, how you're going to track triggers on those. You're going to have to get your routine sample systems in gas vapor, light liquid, and heavy liquid. Everybody know that heavy liquid sample systems still have to have closed loop, closed vent, closed purge? The way NSPSVV applies, tells you the applicability, is in the title of the section. So if you go to 482-7, it's valves and gas vapor and light liquid service. You go to 482-2, it's pumps and light liquid service. So by not saying heavy liquid, you don't have to monitor pumps on a monthly basis like the requirements in 482-2 are. That's all picked up in 482-8 with the AVOs, okay? But if you get to the sample systems, it says sample connection systems. Mute on the service, which means all three, light liquid, heavy liquid, gas vapor, are covered. So that's a subtle one you have to watch out for and that people miss. Your open-ended lines, you got to identify them, get your closure devices in place. You got to start monitoring on your valves sometime in that period. And maybe get some kind of a start on your difficult and unsafe NDE. Few people are using NDE anymore. I think it's more trouble than it's worth. Because unless you, even if you have, say, a bellows seal valve, which is pretty close to NDE, those with vibration, with corrosion, over time can fail. The bellows can puncture or crack, and you can have a leak there. And when you find that with an NDE, that's a deviation. So most people would rather just have it be a leak and you repair it. So they'll go ahead and monitor it more often than annual in return for not having an automatic deviation when and if it does leak. 42-8, you got to be responding to any signs of sensory signs of leakage that your operators or others might report. You got to set up your delay of repair process. At this point, you probably haven't done much monitoring, so you haven't found many leaks, and you don't have much to do there, but you got to have it organized. And you're going to designate a closed vent system going out to a control device, flares for most of us. So you have to know how you're going to do that. You're going to have to tag it, identify it, and so forth. So there's a fair amount of stuff that needs to get done there. Up till, this was probably what, 2011? Yeah, fall of 2011. We all thought it was good, made good sense to get started early and do this stuff as quickly as you could, but that as far as a compliance deadline, we had the full 180 days to complete everything, okay? Now, we had the Alabama Department of Environmental Management, ADEM, wrote Region 4 because they had disagreed with one of the plants in the state about the way they started up, that they didn't get going with their monitoring till very late in the 180-day period. So they wrote Region 4 and said, this 180-day compliance, do you really have, can you wait that entire time, or are there any interim requirements. And Region 4 replied back in a letter back to ADEM that while you had 180 days to fully comply with all, it is not a grace period during which the facility is exempt from work practice standards, and therefore pump and valve monitoring should begin within 30 days of initial startup. Ouch. Ouch. But this has been 2011, and for quite a long time, that never got picked up as an ADI. So we thought, well, somebody in headquarters recognized this was probably not such a great idea, so it's kind of a regional interpretation. ADIs are normally a regulated entity sends a question to an EPA region that they're in and gets a reply. So this came from a state agency to a region. So it was a little bit different. We thought maybe that was their grounds for not pulling up one that they weren't fully invested in or whatever. So we were kind of telling people, you know, it's interesting to know that that's out there, and you probably ought to do your best to get started, you know, early. But 30 days, you know, I don't think in many cases that could safely be done. It's really going to be pressing the envelope. So I would say, you know, be reasonable and start as soon as it's safe and you can do the work with quality. And at that time, it was a regional affair. Okay. You notice we got some strikeout type in here now. In the August update of 2014, this letter went into the ADI. So it now has national applicability. I don't know why it took so long, why they thought about it, but it's there. For better or worse, for worse. There's not much better about it. I got some pros and cons. Suffice it to say, the pros, there's only one. If there's some early leaks on those valves, your monitoring is going to catch those leaks and they'll be repaired a little sooner than they would have been otherwise. Okay? The cons, I've got probably 10 pages of them. We don't need to belabor it since it's not kind of it's less of a judgment call now. So one of the things I learned out of that, whenever I've been on the ADI before, I've always just gone in and done keyword searches. And it's a good idea when you're first working with it to do that on all of the things that you're puzzled about, interested in, whatever. But there is, instead of going through the keyword search, there is also something called check for recent updates. And then you'll get a list. They don't put these things in one by one. They batch them in a couple of times a year. And so one way, once you've already gotten to the point where you think you've found all the ADIs that pertain to you and your questions, and to keep up to date to new developments, is just to go in maybe once or twice a year and look at the recent updates. So that was a new learning for me on this one. All right, so the pros, you find your leaks a little bit earlier. Wow, my microphone seems like it just came on for the first time. Can everybody hear in the back? Am I doing okay? All right. The cons, we're not going to belabor them because they're all over the place. You know, you're going to lose tags. Crews are going to either enter before it's deemed safe, or they're going to be cutting it as close as possible. They're going to need to correct tagging for as-built. They're going to probably have to import a larger crew for both tagging, documenting, and monitoring. And, you know, not to, you know, belittle anybody, but whenever I've seen this situation take place, you usually don't get the quality of work out of somebody who knows he's coming to this site for a week or two and then going away, doesn't have to live with the results, they're probably not going to do the same quality work as the people who have a long-term vested interest in it. So I think you lose quality there. You're probably going to take a lot of time to get all the tags on and get everything identified, so you're going to be smashed into a small number of days at the end of that to get the monitoring done, so it's going to be rushed, and when we rush, we don't do as good a job as when we have the time we need to do it at a normal pace. Safety issues in everything we do is going to be a problem. We've got that definition a quarter. We brought this up about load leveling before, but it also applies here. Again, we ran through that definition, so in our example for one that was starting now, we had to begin quarterly monitoring. Our first quarter would be in May, start in May through July. So there is some kind of implication that if you're going to start quarterly monitoring in May, that you would have to do March and April monitoring in order to have 2 consecutive monthlies to jump up there. That's not quite as constrictive as 30 days, but it does kind of imply an intention of you getting going relatively early and having your quarterly monitoring completed in the first quarter so that you would have something to report in the first semi-annual report. Now, it's actually interesting to note that in record keeping, your first semi-annual report is only required to include a listing of the numbers of components by type in the thing, and it doesn't call out monitoring data. And all the things in subsequent reports, your number of leaks detected, the number of leaks repaired in the required timetable, the number of leaks that were not repaired in the timetable and put on delay of repair, number of leaks that were simply exceeded the timetable without being put on delay of repair, and all that kind of information. But it didn't say anything about putting that in the initial. Only talked about numbers. So that kind of argued back against it, but we're kind of stuck with it now. So the main thing that we have to work as wiggle room if you're subject to VV starting up a unit is that initial startup is not defined at all. So in the absence of that, you can define your own. That it's the day that starts the day that non-essential personnel are allowed on the unit. And that's about all the wiggle room I see that we have to use, which may gain you a week or two, maybe in some cases months. You might not be allowed in the first month, and that, if you couldn't call that solely for testing, then you would be in a deviation mode already. So having that would be useful. I would, if I were going to do that, I would define that in my LDAR program manual and then stick to it, okay? If somebody comes in, audits you, whether it's an agency or a consent decree audit or any kind of audit, HRVOC audit, although that one's kind of very narrow in what it looks at. You could point to it, say, well, there's nothing in the rule that defines this term, so we've defined it for ourselves, and here's what we're using, and we've complied with what we've imposed on ourselves. Whenever I've seen somebody do that, even if the agency differs with your definition, they seldom hit you with a fine on something like that. They'll say, we disagree, you need to change your manual, and in the future do it this way. Okay. But then that'll force them, well, if you want me to do that, you need to make this an explicit clarification. Or you can use it maybe to force them, who knows?
If I could ask.
Yes.
What I think I just heard is, in our LDAR manual, is we define initial starter.
Yep.
And just as long as you're consistent on how you.
Now, if you have Han or one of its clones, there is a definition there. So then the only wiggle you have on that, they don't define solely for testing. So you could put a definition in your manual that says, anytime our unit is not stable enough that they will safely allow non-essential personnel, that's personnel other than operations or critical repair personnel, that we will consider that kind of operation to be solely for testing. Other than that, you're going to have to live with the 30-day. All right, existing units, we can speed this one up a little bit. There's actually a couple of categories. If you had a unit that was in VV and you did some modification work to it that caused it to go up into VVA, okay? Now you've already got your drawings highlighted, you've got your components tagged, you've got it all documented in a database, you've got monitoring history on them. So it really shouldn't take 30 days to get to your next one on that. Shouldn't be a big deal, okay? But if you've got an existing unit that's never had an NSPS on it and it modifies in, then you've got almost exactly the same workload as with a new unit. The only difference is it's probably up and running stable, so you don't have that part to deal with. So this is another one here. That's recently made it to the ADI stage. One of the facilities up in Detroit wrote a letter asking EPA that they were a refinery under consent decree. They were already working at the 500 ppm leak definition required by VVA. Rather than do the rather complex triggering calculations for all of their units, they wanted to just voluntarily adopt VVA plant-wide. And they said, we just want to verify that under that kind of situation, we wouldn't have to start over and monitor all of our valves monthly for 2 consecutive months. And EPA wrote back and said, well, they didn't say about voluntary, but they said you have to monitor monthly. That the trigger for modification, we don't know how widespread the changes are on it, and so you just have to monitor them all monthly. Now, the unspoken thing was, if you're doing this voluntarily, you can do anything you want to. But until you've done it with the monthly monitoring, you haven't fully complied with and adopted VVA. So you still have to run the triggering tests, and then when each unit triggered VVA, you'd have to go through the 2 months of complete monitoring. Not said, but implied. So we got that running around too. These things we can zip through them pretty fast. Just saying that we're going to have pretty much the same 180 days and the same task to complete within that time. All the tagging, flagging, documentation, and monitoring. So this is one where over the last 3 or 4 years, we've gone from thinking we had a pretty clear idea of what we needed to do and what was allowed and what wasn't, to now being forced into a very rapid initial monitoring for all valves and pumps after initial startup. You do maybe have some flexibility on definitions, but not a lot beyond that. And again, these same issues would apply to new units and units that newly trigger an NSPS. Okay. All right. This is a quick one, kind of a fun one. Shows how you can screw up the language. BV says in the test methods, a mixture of methane and normal hexane and air at a concentration of about but less than 10,000 ppm methane or normal hexane is what you're supposed to use. Okay? Remember, when this was written, the leak definition for all component types was 10,000 ppm. And the primary analyzer we were using was the OVA 108. Had an analog scale and had a 0 adjustment and a span adjustment, a single span adjustment. So you could only set it to one calibration gas value. That scale read up to 10,000 ppm. So if you had a calibration gas that was 10,050 ppm, you couldn't set it to that value because it was off the scale. So a forward-thinking person would have written this as a mixture of methane and normal hexane or normal hexane and air at a concentration that's on the within the limits of detection of the analyzer. Would have given you the same protection, but it would have been viable throughout the years. Fast forward, and not many times, but at least half a dozen, maybe 10, I've had plants call me up and say either EPA or their state was hassling them because their cal gas was over the leak definition. And not just the 10,000. Although the 10,000 wouldn't make any difference to us now, and we got instruments that read to 50. So that, but I had people that told me, well, we ordered our gas, we asked them to make it 495, but when they certified it came back as 502, and the state said we can't use this, and they're writing us up as an NOV. That's what this kind of sloppy language gets you into. All right, now this is an interesting one. Kind of touched on something you were talking about earlier. When you start making repair attempts, readings don't always go down, right? It would be nice if they did, if this was just like turning a faucet and you turn it one way, it always got more and more flow, and you turn it back the other way and you got less and less flow until it stopped. It would make our repairs real easy. But real life is, especially for liquid service, when that thing's starting to leak, more than likely you have liquid saturated in the gaps around your packing. And when you tighten the packing down, you decrease the volume of the stuffing box. So you're forcing some of that liquid up through the annular space between the follower and the valve stem. And when that happens, you're going to get a spike. And it may last for a few minutes, a few hours, a few days, a few weeks. And some real borderline light liquid, heavy liquid, maybe more than months. And so what can happen here, and it's not always that, even with gas streams, you can tighten to the point where you cold deform the packing. And it's squirming, one ring going under another and getting twisted around. So there's lots of different mechanisms for it to happen. But what happens with all the, you mentioned you had, 4 regulations on one unit? That's not unusual. an NSPS, a MACT, a state reg, a permit condition, a consent decree. It's not unusual to have 5 or 6. And some of those may have different leak definitions for each one of them. So what happens, let's say your lowest leak definition is 500. So we got a 600 ppm leak on that valve, whatever, and we go to cranking down on it, and it goes to 1100. And we've got regulation 2 that has a leak definition of 1100. So we found a 500 ppm on Reg A yesterday. We made a repair attempt on it and triggered the 1000 ppm leak under Reg B on today. And we make a third repair attempt or second repair attempt day after tomorrow, and it goes over 5,000, and that triggered a leak under Reg C. And then we maybe made one more and it went over 10,000, and we triggered a leak on Reg D. How do we treat all these? Do we keep 4 sets of books for that one leak that started at different times, maybe get repaired at different times? Or do we try to accordion it into what's going to give me the most conservative to comply with everything? So in other words, on that one, if you're going to say, okay, we're going to treat the day we found it at 500 as the day that the leak started for all of the different levels. And within 5 days, we're going to have a first attempt, and within 15 days, we're going to complete it.
Except for your HRVFC, which now could be looking at a 24-hour repair.
Yeah. Yeah. And California has the same thing. At most you have 7 days, and then depending on the ppm level, it could go down to 2 days or 1 day. So yeah, you can have shorter. So whatever the shortest repair cycle is, if you can live within that for all of your different rules, you can compact it and live that way. But the one thing that's a little thorniest about that is that, okay, is the first attempts. Okay? So we had in our example, we found it on day 0. Day 1, we made a first attempt on the 500 ppm leak. Okay? Then it went to 1100. Now, if we don't make another attempt within 5 days, then in the database, if they search on that one rule, they're going to find that you didn't have a first attempt for that rule's leak definition, because you only triggered that this day and it went forward more than 5 days. So the only way to make that work is you've got to have an attempt no more than 5 days apart. You got to keep having attempts through however long your shortest reg would require. So then the other way is to actually keep it parallel. So you would have that 1100 ppm, and you would do immediately another first attempt, if you want to call it that, by the monitoring technician, and record that. And then if it goes up again, you do another first attempt immediately there, and keep different timetables for each of those rules. The databases can sort of track that, but it is getting into the kind of area where they can stumble over their own feet.
What about putting that in your own plan on how you're going to
So I think it's a wonderful idea.
and actually, go back to, depending upon what you decide, that the first leak is the leak definition, and that's what you have to comply
Yeah, and you're going to repair it within the time allowed.
by whatever the reg
of
was at the leak, leak finding.
Yeah. All right. Well, we kind of talked through the examples, but same thing. All right. Most defensibles keep separate books so that you get it all there, but somewhat more workable is to put everything within the shortest deadline that might apply. All right, capital expenditures aggregation. Those of you that have been around for a while, you've talked about these things, you've heard various things come together, but typically 1 to 2 years is the period you might aggregate expenditures towards deciding whether you trigger a modification or whether you trigger PSD or any of the other types of things that are out there. When EPA brought the oil companies to the table to negotiate consent decrees, they alleged that they believed that the companies had intentionally limited the amount of work they would do at each turnaround, maybe 4 or 5 year periods, to stay just under the modification threshold. And their option was, you can go to the table and negotiate with us on some beneficial environmental improvements to your program along with a civil penalty, or we'll come in and go through your books from the day you first started this unit, and we'll look at every project you do and we'll calculate whether or not it triggered it or not. And if we found it was triggered sometime in the past that you didn't apply, then we'll charge you $10,000 a day from then to now. And so obviously, most people said, well, let's sit down and talk about this. We don't have to get nasty. So that was a very effective way to get whole corporations, multiple plants to the table at one time, accepting some requirements that would have been very difficult to promulgate as a new rule. But and that kind of implies that actions are cumulative over any time period to be considered in a triggering mechanism. And that has never really been the practice. So we'll look at some of the things there. Oh, that was all of it. I think is it reconstruction, Chris, that specifically talks about a 1 year period? Thinking it is. You remember that one? All right. So we finally finished the gray areas in NSPSBV. We've got about 7 minutes till lunch. We can probably get triple G out. There's just a few of these because it's a very short rule. Triple GAE, even less, but the one that it's got is a doozy. Okay, hydrogen compressors. They have an exemption for hydrogen compressors if they're over 50 volume% hydrogen. This is the only place in all of the LDAR regs that they use volume%. So I know why. It's the most common way. If you send your hydrogen to your lab for a purity check, it comes back in mole%, which is same as volume%. So maybe that was why they did it. It's really not too gray on the compressors, but where we do get people confused and making a mistake is the compressor itself may be exempt, but all the piping and the components on the suction and discharge lines are just subject to the 10 weight% applicability. They're not on this 50 volume% exclusion, which is only for the compressor itself. And when you go from volume% to weight%, where hydrogen is a major component, molecular weight 2, if you go up to propane as the lowest molecular weight saturated VOC, 44, so you got a ratio of 22. So if you have a 0.5% by volume of C3 plus in your recycled hydrogen, it's over 10 weight%. And that's one that a lot of people miss. Light liquid definition. This one's not really gray too much. You know, the one in VV said if you've got more than 20% of the chemical components that have a vapor pressure over 0.3 kilopascal. My favorite unit that everybody just has a gut feel for what a kilopascal is. But yeah, if it's over that and 20% of your components have a vapor pressure over that, it's a light liquid. You get into a refinery, we say, hell, we can't even define 20% of our components. So we got isomers out there that, you know, after C8 or 9, there's dozens or hundreds in the 10, 11, 12 carbon numbers. You know, so we can't identify all these things, and we don't have vapor pressure data on all of them either. So they said, okay, what do you do on a regular basis? And they said, well, probably our distillation test is the most common thing. So they got their ASTM D86, and they actually wrote this into the rule that if 10% or more evaporates by the time you get to 150 C, 302 Fahrenheit, that's a light liquid. If you have less than 10% evaporated by the time you reach that, or you don't reach the 10% point till higher than 150 C or 302 F, then that's a heavy liquid. Okay? So the thing that's a little funny about it is that they didn't explicitly say this could be used by other facilities. As you got things like ethylene plants. They have streams in there with giant mixtures of stuff coming right off the reactors and so forth. So really this ought to be made available to anybody that where you can't really define all of the components there. There's an interesting story on that. The Bay Area out in California, the AQMD there, picked this up, but they, instead of putting 10%, they put initial. It's the initial boiling point, that's the temperature at which the first drop of vapor condenses and drops down into the receiving vessel. Hits. So literally, that would take light liquids all the way down through diesel, kerosene, avjet, and probably number 6 oil. Maybe number 6 oil. Thankfully, they didn't realize what they were doing. Nobody has considered all of those lighter end heavies to be light. And so they just ignore the fact that they screwed up the language, and they're going on as if it said 10%. That's the kind of thing that, you know, somebody is going to see that and start wanting to apply it someday. I just know they are. That's the way enforcement works. But we'll see. All right, and they also put in an asphalt exemption for open-ended lines in triple G and triple GA. Why would they do that? Yeah, it's very, very heavy. Not much volatiles in there, so you're not going to have much of a vapor leak from it. But why, if that was the case, why not exempt all heavy liquids from open-ended line requirements? Why just asphalt? I suspect it's a safety issue. I suspect that somebody closed a valve, put a plug in, it leaked through, the ambient temperature cooled it, it solidified. The operator comes out, he's supposed to drain this thing. He pulls the plug, he opens the valve, nothing's happening. He goes and gets a steam hose, gets that on there, he gets a rod, starts rodding it. Pretty soon he breaks through, and hot pressurized asphalt sprays out and burns him. So I think it was that kind of scenario. But even then, why just asphalt? Why not anything that would solidify at common ambient operating temperatures? I don't know. So if you want to use it for anything else, that's a risk-based extension. They've only got it in there for asphalt. Then we got the trigger exclusion language. almost every one of these rules, kind of the last sentence in applicability has something like this. And this is the one in triple G. It says, facilities subject to VV, VVA, or KKK of this part are excluded from this subpart. So if you're already on one of these that all point back to the requirements in NSPS VV, then you don't have to do triple G. Makes sense. But the one in triple GA says facilities to subject to VV, VVA, triple G, triple K are excluded from this subpart. Some people are reading that and interpreting that once you're subject to triple G, you can never modify up into triple GA. I'm relatively certain that was a typo or a mistake. So we got some interesting arguments on this one. You can look at the way excluded has been used, and most of the time it's excluded from the requirements. So the triggering is in the applicability, not in the requirements. So maybe that's what they meant, huh? So that's basically, we already talked through that stuff. Preamble guidance, these requirements will only apply to sources that commence construction, reconstruction, or modification after the November 7th, 2006 proposal date. So they're saying that you could modify in, but that could be an existing plant that never triggered triple G could now modify into, triple G could modify into triple GA. Okay, so it's still not explicitly saying you could go from triple G to triple GA. And look at it, impacts. They estimated the number of new and reconstructed process units. They didn't estimate the number of modified. That kind of makes it sound like they weren't expecting you to modify into triple GA. So we got these things kind of offsetting each other, neither one explicit. Then we have out of Washington State, one of the refineries was doing some extensive rework on a crude unit, and they wrote in, it was already subject to triple G, so they wrote to Region 9 and asked them whether that would trigger triple GA or not. And they got a letter back that said, well, the letter that they sent included a conversation that they had earlier had with somebody in headquarters, in OECA, I can never remember the name for that, the Office of Enforcement and Compliance Assurance, maybe, something like that. And on the phone, verbally, one of the EPA people said, of course, you can modify up from triple G to triple GA. The people in Region 9 looked at it, sent the refinery a letter, I've got a copy of it if anyone would like it, saying that they considered the language to quite clearly indicate that units subject to triple G would be excluded from all applicability to triple GA. And they indicated they found no other reason to go forward with that or to doubt that. So we've got two EPA offices that can't agree on this one. Exactly what the ADI was put together to avoid. So the conclusions on this, it's still up in the air. Region 10, if you're out there, you can certainly use their letter. If you're not, you can use it anywhere in the country, I would think, if you wanted to do that. My guidance would be, as long as it's that much up in the air, not to voluntarily move to triple GA, or to voluntarily, or to consider yourself triggered to it, keeping a copy of that region 9, 10, I thought it's 9, I'm not sure, determination as your basis. Make that, again, part of your program documentation. Then if somebody comes along and says, no, 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 they were wrong in region 10, you say, okay, well, I was following EPA guidance, so I can't see how they're going to get you in too much trouble. So that's that one. We're going to